Okay, we're in section 69 of the notes. Contents, examples, exercises. This section is a little bit of exception. They really have no content, no examples, just exercises. So it's a repeat of the past. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells's Advanced Course in Algebra, which dates back to 1904. And excuse me, I had to close the door. So what I'm going to claim over here is that that this document, the PDF you're looking at, is being made available to the participants in the Prison Mathematics Project. Right? I realize there's instructors and students looking at these videos wondering when they can get access to this document. It's not published yet, but if you want to reach out to me at my email address, that's B as in boy, the @ NNON.US, and I'll let you know when it's going to get published. Now, again, I said this section is like an exception to Wells's normal technique, but he does give an introduction. It's going to be, there's going to be more of these simultaneous equations of higher degree, but they're word problems, all right? He gives no examples, all right? No examples whatsoever. So what I'm going to do is I'll talk about, if I were doing the homework, it's something to do with the past at this point. And I realize a lot of students reading these things, they have a very difficult time with word problems. You're not alone, by the way. But, reading it, I know they're talking about two numbers, the product of the sum of two numbers. Then they call one a small number and a large number. So I'm going to say x is the smallest number and y is the bigger number. I want to read the sentence again to you. It says, the product of the sum, well, the sum of those two numbers is x plus y. Now, they say the product of the sum and the smaller number. Well, I called x the smaller number, and where they claim that's equal to 21. Now, the next thing to say, their product of their difference. Now, the difference is the larger number minus the smaller number. That's their difference. And it says the greater number. What's the greater number? The greater number is y, and that equals 4. That's just from the reading of it. Now, I'm going to get my eraser out. Erase this business over here. Erase my highlighting of this. And I want to claim that this stuff is written down here. All right? So, again, if you're struggling with this, you struggle one piece at a time. Just make sure you're you're going along in the right direction. So I'm seeing the first equation, which is x times x plus y is 21. I see that. And I see the second equation, which is y times y minus x equals 4. I see that. All right? So it says, how are you going to solve that? Well, one thing you can do is just simply multiply it out. If you do that, what do you get? Let's write this down for you. You would get x squared plus xy is equal to 21. And the second equation, you get y squared minus xy is equal to 4. And you could add them together, and what would you get? Well, you get something pretty simple. You get x squared plus y squared is equal to 25. Now, by the way, that's a dead end for me. I'll tell you why. There's an infinite number of x and y's that would fit that condition, right? So that's not going to help me. I'm not going to determine what x or what y is under that. I can give a range for it, but beyond that, I really can't get much out of it. So I'm going to erase this over here, indicating it's a dead end. I'll erase this line here. And I'll try another strategy. And it's going to happen to you when you're trying to solve a system. You can say, I'm going to do a different strategy. Well, I'm going to take the first equation, and I'm going to solve it for y. And what would y equal? Y would equal, this is the first equation, it would equal 21 minus x squared over x. And then I'm going to take this y and substitute it in the second equation. So I'm going to put it right here. Let's see what you get. You're going to get 21 minus x squared over x squared minus x. Well, what's the y? It's 21 minus x squared over x, and that equals the number 4. All right? Now, what am I going to do now? I'm going to try to simplify it. All right? You get, it's tough, though. You get 21. I want to get my eraser. I need more room. I get 21. Whoops. Did it again. 21 squared minus 42 x squared plus x4 all over x squared. Well, that's done. Let's do the next term. The x cancels off, so I'm left with minus 21 plus x squared is equal to 4. Now I'm going to multiply both sides of that equation by x squared. And what do you get? You would get 21 squared minus 42 x squared plus x4. Again, I'm multiplying by x squared. Minus 21x squared plus x4 equals 4x squared. All right, I'm going to rearrange it so it's in proper order. I like to do this descending powers. So x4, there's two of them, right? Let me get my highlighter out to make sure you know what I just did. I did this one, I did this one. Now I'm going to do the x squared term. Right, so I'm looking at all those x squared terms. This one, and this one. And if you got them all on one side, and use the zero product rule, that's going to be minus 63, minus 67. These numbers look really bad, don't they? And then what do you get? You get plus 21 squared equals 0. I'm going to use the AC rule. I know Wells talks about the AC rule, but not by name. Nowadays it's called the AC rule. It's not bad. When the numbers get big, I do use it. So 2 times 21 squared. I'm going to write that a little bit differently for you. That's 2 times 3 times 7 times 3 times 7. And I got to find two numbers that would multiply together, give me that. But I got to find two numbers, the same two numbers, by the way, add up to minus 67. So I know I got negative numbers. I got to play around with it. And I'm looking at it, and I'm going to say, 9 times 7. 9 times 7 is 63. If it doesn't work, I can try again. 63, and 2 times 7 is 14, right? That's not going to do it. 3 times 3 is 9, 9 times 7 is 63, and 2 times 7 is 14. So that's not working. Let's try another one. I'll erase this over here. Let's try another one. So let's see. 7 times 7 is 49. Let me try that one. Get my eraser out. 49. Let me point what I did over here. My eraser. I just did the 7 and 7 now. What's left over? The 3, and the 2. That's 9 times 2 is 18. Well, that's 57, 6. That worked beautifully. So let's write that down. So 2x4. Let's see. I'm going to put down, let's see. Oh, they're minus. I'm sorry. Minus 49 x squared minus 18 x squared plus 21 squared equals 0. All right, let's see if we can do that. So you get x squared, and you would get what? 2x squared minus 49. Okay, let's look at this then. I'm going to factor a 9 out. You would get 2x squared. And remember, 21 squared, if I factor a 9 out, which let 7 times 7. Did I do that right? 21. I'm factoring a 9 out. I think I made a mistake somewhere. And I got to think about it. Put a minus sign over here. I got to think here for a second. 49 and 18, 57, 67, 21 squared. 21 squared. Oh, I'm sorry. Let me put that down. I was doing something different. That's 3 times 7 times 3 times 7. I'm sorry. I was looking at something different. I was looking at this, and I didn't see it. 7 times 7 is 49. You fill out the 9, so you get 49, as expected. So what do you go over here? 2x squared minus 49 times x squared minus 9 equals 0. And you know what? I got 4 solutions now, and I'll write them down for you. You get x equals plus or minus 3. It's a lot of work, right? And what else do you get? You get x equals plus or minus, that would be 7 over root 2. Yeah. Kind of jamming all this stuff in here, aren't I? Let me get my eraser out, get rid of some of the older work now. Again, if you're doing this on paper, that's fine. We're just working over my notes, by the way. I'll get rid of this thing over here. And I think I can possibly talk about it now. And what I mean by that, if x is 3, I wonder what y is. Well, it'll be 21 minus 9 over 3. And that would give you 7 minus 3, which is 4. Now let's try minus 3. Now if you did that, what are you going to get? You can get 21 minus 9 over minus 3. What's that going to give you? Well, I'll give you minus 7 plus 3, which is minus 4. All right? They're kind of done. I get my eraser, I get rid of my chicken scratch over here. The roots are more difficult. All right? So let's put that down for you. What do you get over there? 7 over root 2. Let's pop that in there, see what you get. You get 21 minus 49 halves. Divide by 7 over root 2. It's a nightmare. There's no doubt about it. Let's see if we can do that. Let's just do the top first. That's 42 minus 49, which is minus 7, over 2. And we're dividing by 7 over 2. It's like multiplying by root 2 over 7. So what do you get there? You get root 2 over, minus root 2 over 2. That was easy. All right. If you do the next one, I'll write that down for you. That would be minus 7 over root 2. Yeah, these are tough problems. I know that. And if you did that one there, you're going to get, these nice and symmetric, aren't they? You get root 2 over 2. All right. I'm going to just look at the key now. And I want to see if I got those answers. I'm not checking in the original problem. I'm just checking in my key. Well, they rationalized it, but it's still the same number. So make sure you get this one over here. I see it. And do I see this one here? Yep, I see it. By the way, I'm not saying they're right. So I got 4 solutions. I am not claiming they're right. All right? So what I claim over here, I know it's really tedious to do this. I'm going to start to erase all my work now. So I got 4 solutions by, doing all that work. I got them all. I got all my solutions. But I'm not saying they work. I'm just saying I got a bunch of answers over here to check. Now someone says, why do you want to check them? I don't know if they're right. I mean, I just did some basic manipulation with algebra, but I could have introduced all kinds of problems into this. So what I want to do is I want to try one at a time. So I want to try this guy right here, because I think it's going to be easy to try. And what do you get? Before I do anything, I want to point out that I got ordered pairs over here before I do anything. I want to make sure I know that y is the larger of the two numbers. Well, right now, this makes no sense, because minus 4 is not larger than minus 3. All right? I know that much. All right, I'm going to look at the other ones. I'm going to say, let's see what else. This one makes no sense, because that y is not larger than the x. I'm going to just cross those two out. All right, they're gone. I'm not going to look at those again. All right? I'm going to look at the other ones, though. And the other ones are going to be 3, 4. Let's just put that down. So x is 3. And then I got 3 plus 4. Does that equal 21? Bingo. Yes. Let's do the next one. It's going to be 4 minus 3. And what does that give me? 4. That also works. So I know this one works. This works. It works. Works nicely. All right. So I'm going to just cross out my chicken scratch. And I want to try the other one. I know it's tough. Someone said, I don't want to try it. I want to try it. And I'll try this one over here. So let's write this down. So the x is 7 over root 2. I'm sorry, root 2 over 2. I'm checking this point over here, by the way. And then I need to add those two numbers together, right? And what they give me? That would give me minus 6 root 2 over 2. Well, this looks pretty easy to multiply out. The bottom would be 4. The top would be, let's see, 42 times 2. 2 goes into 2 once, goes into 4 twice. 2 goes into 42 21 times. So it makes pure sense here. Let's do the next one, and that's going to be y. And what's y? Root 2 over 2. Now I got to put the difference down. And the difference would be root 2 over 2 minus a minus, so it's going to be 8 root 2's over 2. Let's multiply it out. You get 8 times 2 on top, and at the bottom you get 4. Well, 4 goes into 4 once, goes into 8 twice, and 2 times 2 is 4, and that works. So they're the only two that make sense. Okay, also want to claim what I do is I graph the system out for you, and it says it's figure 189 on page 1226. Those page numbers may change, and the figure numbers may change, all right? And what do I see? I see those solutions over there. Now, someone says, what solution are you seeing? I'm seeing the solutions that we said would work, 3, 4. Where's that? Right over here. And the other solution we're seeing is going to be that minus 7 root 2 over 2. Comma, I'm just copying it down, root 2 over 2. And where's that point? Right over here. By the way, there are other points over here, but they're not making any sense with the wording of the problem. I know that's difficult. We're encouraging you to try. All right? In other words, thinking about what your answers mean when you do it. And again, I make mistakes too. So if you're looking at some of my work over here, you may want to comment on that. So let me just say, I've done one, you do the others. And there's problems, and they're not easy, all right? Who does the graphing? The machine does the graphing, by the way. But anyway, a lot of problems to think through. I do provide graphs to support my answers, by the way. But again, could I misread something? Of course I could, all right? If you're looking through these problems over here and you think there's an issue with it, yes, there's a lot of questions. Bring that issue to my attention, all right? Bring it to my attention. All right, so I want to just, go through that and get to the Sage business over here. Oops, sorry, I didn't mean to do that. What's Sage? We've been saying this a lot, haven't we? Computer Algebra System, CAS for short. It's open source software. Go here. You can either download it or use the interactive web-based application. And you can be surprised that Sage can actually solve these systems. All right? And it really does, it does quite a good job at it. And it's certainly a lot faster than I can do it by hand. Which really you probably ask yourself, why would I need to learn to do this by hand? You really need to learn to do simple things by hand. Now, I realize some people may complain, these questions are not simple. Why don't I just use a machine to do that? Not a good idea. I'm going to say, yeah, maybe they're not that simple, but you can do them by hand. Every problem I did by hand, right? I did not resort to using a computer. But I do want to point out that at some point, you're going to be starting to use a computer because the problems get so big, you're going to need a computer to do the problem. All right, that's a given, right? If you proceed forward in mathematics. But anyway, if you think there's an error in anything I wrote in my notes or in the problems that I gave you, let me know. How do you let me know? By email. And if you let me know by email, and I agree with you, and I'll certainly entertain any things you're saying, I'll put your name in the document if you want it. Right? I should say I'll put your name in a document unless you don't want it. Then I'm not going to put your name in it. But you have to specify that when you write me. Okay? Thanks for paying attention.